Hello, and welcome to another one of my recordings on um, some few of the concepts that we've been covering in class. Through this recording, I want to go over essentially chapters 4 through 7 of your textbook. Chapter 4 essentially discusses control structures, which is the if and the switch statements. If I go to chapter 5, you'll notice we're doing repetition, essentially looping in C++, which involves the while loop and the do while loop and the for loop. Chapter 6 discusses user-defined functions. This is where you get to create your own modules. Of course, functions are great for creating modular programs that were uh, tasks that are common to a lot of applications could be actually grouped into individual functions, and then the functions can be used and reused. Essentially, with functions, we define them once, and then we use them as many times as we like them to be used. Chapter 7 essentially talks about enumerations, namespaces, and strings. I'll put a note in the class, I guess, about this. On this chapter 7, really the thing that I really care most about is the string type. And even on that, because we haven't really talked about object-oriented programming and classes and objects, some of that stuff may not be too obvious, but I'll kind of explain what what we need to be covering in that chapter. Enumerations are okay. I hardly ever use them myself. And discussion of namespaces should really be deferred to the next class, the CIT 233, when we actually discuss object-oriented programming. Okay, so let's go ahead and briefly go over some of these concepts. I'm hoping that you already know about the if statement. Essentially, and maybe I think this slide does it justice in the sense that the if statement, you check a logical expression, and if the expression is true, you perform these statements. If the expression is false, you perform these statements. Of course, looping structure, ifs and loops look pretty much the same, except that with a loop, you repeat a process. And all you have to know is how to create a logical expression. And for that, of course, all you have to do is, I'll talk about all of these stuff a bit later through this recording. So if I have a variable called age and I set it equal to 23, again, of course, that could be input. I could ask a question like if age is well, greater than, let's say if age is greater than or equal to 13, and of course we use the 2 ampersand for the AND operator, and age is less than or equal to 19, I could actually display a message like you're a teenager. Um, and essentially, what's important here is the logic of the if statement. If this is true, we execute the statement. If it's false, we don't. Now, if you have multiple statements to execute, we want to put it inside a pair of brackets. So if you only have one statement to execute, you don't need the braces. But it's a good idea to always put braces because if you decided to come in and add more statements, you can easily add statements between the brackets. Of course, if you don't do the brackets, the only statement that gets executed is just the one statement after the if. Now, of course, you can also do an else clause where you could do else cout. You're not a teenager, you know. So again, in this case, this is a two-way if statement in the sense that either this condition is true and you perform this operation, or the condition is false and you perform this operation. Of course, again, you probably want to put uh, braces just to be consistent. Okay. Now, a multi alternative approach is when we use a series of else-if statements. So if age is between 13 and 19, you say you're a teenager. Else if age is, let's say, greater than 20 and age is less than or equal to 50, let's say we say you're an adult. Again, all I like to do is put in the brace here, and I guess I should fix my tabs, but I'm sure you all know how to do that. You're an adult. And again, tabs and stuff like that always depends on the IDE that you're using. So we do an adult, and then we go here. So there, that's all it is. You enter the age, or well, actually, let's say instead of this, let's actually ask the user to enter the age. And then you can decide based on the input age what to do with it. So we do that and that. So if I ran this code, and what I'm going to do is I'm going to comment out this other code that I'm going to talk about as soon as I'm done with these, with the ifs and the loops. So I comment that out. And so if I run this code, and I'm going to go ahead and press compile and run. Hopefully I don't get any error messages, but it looks like I am getting an error message because I put a 7 instead of an ampersand. Well, easy to fix. Compile and run, and enter your age. I put in 23, and it tells me that I'm an adult. Is that, I misspelled your also. Is that correct? Yeah, looks like 23 is bigger. It's not between 13 and 19, but 23 is bigger than 20, and it's less than 50, so adult is created, and we end the code. So let's go fix this thing. Kind of embarrassing. All right, so if I run this code again, press compile and run, and if I put in 80, it's going to tell me that I'm not a teenager. Okay, the logic has some problems in it, but you obviously see where you can go with this program. So you can have an if, a series of else if, and an optional else. I always put an else clause in there. That way, if there's anything that I haven't caught, I'll put some code in there just in case we ever get there. All right, now, if I want to repeat this process, let's say I want to repeat this process 5 times, well, the easiest thing to do, because I know how many times I want to repeat this, is to create a loop that where we say if I equals to 1, I less than or equal to, let's just say 3 times I plus plus. Again, you have your brace, and then I need to end the brace here. The indentation is a little bit off, but that's okay because I didn't design this properly. So essentially all of these have to be indented, like so. So I just highlighted it and pressed the tab key, and it indented it for me. Okay, so if I ran this code, again, go to execute. I don't want to press F9 because that will mess up with my recording, so you guys can just press F9. Of course, this is only true if you're using def C++. So enter your age. I put in 76 or 67. This is another teenager. Put in 14. I'm a teenager. Put in 20 or 45. And it says you're an adult. And of course, the program ended because my loop was loop ended at 3. Of course, this 3 could also be asked by the user to perform the same operation. Now, instead of this for loop, I could also use a while loop, which is another way of looping. And the nice thing about the while loop is that you use while loops when you don't know upfront how many times you want to repeat the process. So if you're asking users to enter values, you're going to get, essentially have to use a loop. And I usually just use the pretest while loop because I think it just makes a lot more sense. A while loop essentially has 3 things associated with it. Well, actually, a for loop does the same. We always need a loop control variable that we initialize to something. We need a conditional So the statement so that we know when to stop the loop, and we need to change the loop control variable. So all I have to do here is maybe go here and say int I, and I'm going to start it at 1, and then I'll say while I is less than or equal to 3, so that's my loop condition. And I've got my bracket, I'm going to comment this out and put this in, so that way we have a while loop. Now, of course, this is going to work exactly the same way, except you'll notice when I is 1, 1 is less than or equal to 3, it'll do all of this, but before it goes back, I didn't change the value of I. And as you may have guessed by now, if I don't increment the value of I get an infinite loop because I never changes. I stays at 1, and 1 is always less than or equal to 3, so the loop never terminates. And I usually just press Control C, or I just close my window if I get into a infinite loop, and just try again. So let's go over here to execute. This should work exactly the same way. It says enter your age. I put in 1, I put in 2, and I put in 3. And again, it always went to the else clause because none of these conditions were true. So for loop, pretty straightforward. We use it with arrays because, which is later chapters, because we know how many times we're going to repeat or process an array. We usually use while loop if for places where we ask the user to enter values, and then when they're done, we'll ask them to enter some sentinel value, so we'll stop the loop. So again, if you already know how many times to repeat the loop, a for loop is the way to go. Okay, so that's essentially for loops for you and while loops. Let's go to chapter 6, which is user-defined functions. Of course, by now you've used a lot of functions um, that C++ provides for you. The mathematical functions like POW, or I forget what else we've used. Even predefined functions like cin and cout, we've actually used them without really knowing how they're created or how they're defined. So if you want to create your own functions, you can in C++. The idea with functions is that you want to define the function once and then use it as many times as you want. You can also use functions to make your programs a bit more modular and easier to follow. So let's see if we could quickly, I look at this code from here all the way to here. And all I see it does, it asks me for, well, in this case, three age values, and and it gives me a status based on the age. Well, this, I think, to me, is a good candidate for a function. So what I'll do is highlight what I think is a good candidate for a function. I'm just going to go ahead and do a Control X to cut this thing and replace all of that with a function that performs the operation. And I think if we had to name that, I guess this would be something like process age. So, boom. So I have a function called process age. And notice I haven't done anything yet. I just said, well, when you get here, go look for a function called process age with no parameters. There's no parameters in there, so you have to put empty, essentially a parentheses with nothing in it. And of course, I have to go in and define my function. What we should do is we will always define functions at the end of our programs, at the end of the main program. By the way, usually functions are defined in their own files. And that's something, creating projects and having multiple files is something that we talk in CIT 233. So right now, all I have to do is create the function header, say void. I think it was called process age. I guess, was it age or ages or age? And you have the open parentheses, close parentheses. press enter. Here's the beginning of the function. Here's the end of the function. I'll usually just add the placeholders so I don't make any mistakes as far as the opening and closing parentheses or brackets in this case, and I paste. So there, this all of this stuff should run just on its own without any problems. And process age is the name of the function that we just created. Now, because these functions are created or defined after your main program or your main function, you actually have to go up here above this and create your function prototypes. Now, function prototypes are really easy to create because really all they are is essentially the header of the function. So I'll just copy that and go there and paste it. And because it is a statement, I need to put a semicolon at the end. So this tells the compiler to expect a function named process age that does not return a value and does not accept a parameter. This is something else that we'll go over in a few minutes. So this, if you had to guess, of course, this is another function that is named getValues. It does not return anything, but it accepts two parameters. And it just happens that we call it first and second. Of course, these could be any names that you want. As a matter of fact, you don't even have to name it anything, which I'll show you in a few minutes. Okay, so this program runs from main. And first thing the runtime environment sees is process age. So it'll just skip all of these statements, goes here, skips all of these, goes looking for process age, and performs all of these operations, and then comes back and goes to the next set of statements. Of course, I don't have anything else in there, so that's what I expect to get. Essentially, just the calling of the process age. So this is what we refer to as calling a function. Okay? So when you refer to the name of the function, you're calling the function. All right? So we go here and run it, and again, I didn't expect any errors. Enter your age, 1, 2, and 3. And of course, I come back to the program and I'm done. Now, the nice thing about this is that if I just commented this line of code and rerun this code, none of this stuff is going to appear, and which is a good thing, because if I was just testing every unit of the program, I say, well, I'm done testing this unit, so I'll just comment it out. I test all my other units, and then when I'm happy with the whole thing, I'll come back and I uncomment this. So I'll comment it for now. Okay, so that's basically creating a function that doesn't have any parameters. Now, I earlier created this function. It says void get values int first, int second. So if you can see by this is that the name of the function get values, it doesn't return anything, so you can't have a return statement in the function. And it accepts two parameters. As a matter of fact, you can have a return statement, you just can't return a value. All right, so I'm going to go here, and it says get values. I'm going to uncomment my code that I originally had up to here. All right, so you'll notice I created two variables, f and s, and I called get values just like I did process age. And let's see what happens with this code. F is 0, S is 0. I call get values with the two values, so it takes 0 and 0 as F and S. I'll go look for the function. So now first is the same as F, and second is the same as S. And remember, this is what we refer to as the signature of methods. Notice you have two parameters, they're both integers, and the receiving end, you have two parameters, they're both integers. The type and the number of the parameters have to match. Okay, so I go inside here and say first is 10 and second is 20. So what I expect to do is to change the value of first to 10 and the second to 20. So when I come back, F and S will be the same as 10 and 20, or at least that's what I hope to get. So when I run this code, I hope to get 10 and 20 for f and s. Now let's run this to see what really happens. Notice it goes in, it calls the function, it does its thing, but when it comes back, f and s are still 0. The reason for this is that by default, um, these parameters are passed by value, meaning that the C++ runtime environment uses the same uses the same values or uses the values of these variables as it passes the values, but it doesn't do anything to the memory location where they actually refer to. So even though first and second are changed to 10 and 20, when you come back, those values are still exactly the same as they were before. So to fix this problem, we have to call our parameters, actually only the parameters that we want changed inside the function, by memory location or passed by reference. And again, this is also fully covered in chapter 6 of your textbook, so I hope you've read that chapter. So all we need to do is go up here, put an ampersand before the first, put an ampersand before the second. Again, you don't have to put the ampersand before all the parameters, only the parameters whose values you want changed inside after coming back from a function. So you put the ampersand here and there. Of course, you have to move down here and do the exact same thing. Put an ampersand there, put an ampersand here. And now you're calling by address or calling by reference. So here when you say first equals to 10, the value of f, or both the variables f and first, now refer to the same memory location. And because first is holding 10, f also holds 10. So when we execute this program, you'll notice f is 10, s is 20. I made the change inside the function, and that change was reflected outside of the function. So again, the rule here is that if you make any changes to your parameters inside your function, and you want those changes to appear outside of the function, you need to call by reference. And the call by reference essentially means that you have to put the ampersand sign before these parameters. Now, what I was saying is that in your prototype, the compiler really doesn't care about what you name these things. So I can just get rid of the first and get rid of the second, because all I'm telling the compiler to do is to look for a function that accepts two parameters passed by reference. It doesn't really care what they're named. So when I do this and run it, you get the same thing. So this is the preferred way of creating the header or the prototype. Essentially, you don't have to specify a variable name here. Okay. And again, remember the whole purpose of functions is so that the names of these parameters don't really matter. All you're doing is, because I could, call this function with different names. I could call it with s and f. So notice this is f and s, and this is first and second. They don't really have to be the same name as long as they match in type and number of parameters. Now, what I was saying is that, the function get values doesn't return a value. You could go ahead and put in a return statement here. And we usually do this with if statements inside the function. So we say, well, if first is greater than 0 or less than 0, we probably want to return from this function. So we just do a return statement. Notice if I run this thing and run it again, and I get the values of 10 and 20, and everything was fine. If I go ahead and put in the return here, remember a function can only have one return statement executed. So if you have if statements, you can have multiple return statements. You just can't have two return statements executed. So I'll go run this thing. And notice f was 10, but before I set second to 20, I returned from the function, so s is still 0. So the only thing you can't do is you can't say return, I don't know, 25 or something, because this function doesn't return a value. Notice you said the function is void, so you can't return a value to it. So void functions can have a return statement, they just can't return anything. Okay, so there. That's your function. Now, what I want to do is maybe go ahead and comment both of these statements also, so I won't be bugged with that. And then the next chapter, well, that's it, I think. The string on chapter 7, like I said, the most important thing that you have to get out of chapter 7 is the string data type. Strings are kind of special because they're not primitive data types like int and float and double. They're actually objects created from a class. Again, we'll talk about object-oriented programming in C++ if you take the CIT 233 class next semester. So, but the nice thing about them is that they behave as a regular variable. So, for instance, I want to uncomment all of this stuff. So notice I've created a variable called str. Of course, we worked with strings back in chapters, I guess, 2 or 3 also, so this is not new to you. Str equals to hello. I just grabbed the value hello and put it in the str. Now, because str is a object of a class, the nice thing about objects is that they have predefined functions. So notice there's a function called length. That gives me the length of the string. So hello has 5 characters. Str.length is going to give me the 5. Notice they have a function. Now these functions are defined or actually explained on page 480 of your textbook in chapter 7. So you could take a look at all the different functions that they have. There is a function called at. Essentially, all it does, it gives you the character at a specific location. Now, strings are essentially arrays of characters. Again, we'll talk about arrays in chapter 8. The first string position starts at 0. So notice this cout is going to give me string at position 0, which is the letter H. And then I have a loop that starts from 0 and goes up to string.length. Notice I didn't say less than or equal to, because if I did, this string only goes up to character number 4. So H is 0, 1, 2, 3, and 4. If you put the equal sign here, you go over the bounds of the array and you'll get an error message. So as you might expect, I'm going through this loop and I'm going to essentially display every character on its own line because I have the end line here. So I'm going to go ahead and press execute, compile and run, and notice HELLO is written all in one line. Of course, this first H was because I had the string at 0. So let's just quickly see what happens if I put an equal sign there. All right, so go execute, compile and run, and what did you see? This application has requested the runtime to truncate, what is it? I can't even read it. Essentially, I crashed my system. I crashed the program. So you want to avoid doing stuff like that at all costs. Otherwise, and that's why, by the way, regardless of what programming language you use to write your programs, you always want to save your files before you run them. I'm going to go ahead and close program, and I'm hoping that that shell or that process finishes gracefully. The nice thing about most compilers is that when you execute, compile, and run, it saves the file for you, so you don't have to worry too much about losing data but it is possible that you may lose data if the thing crashes and you haven't saved anything. Okay, well, I talked about ifs. Where is the if? Somewhere here. I talked about the if, the while, the for. I talked about functions. I talked about return types. I talked about passing parameters by reference. And also talked about some of the features of using the string class. So that's a lot of stuff. I hope you realize that. I'm going to stop right here. I hope this helps a little bit. Again, if you have any specific questions about this example, post it in the discussion forum. I will also post this file so you'll have access to it if you want to, play with it and make changes and see what happens. Okay. Goodbye for now.